Hey everyone, I wanted to send you one more video on um, sampling, especially coming out or starting from some of the or seeing some of the discussions that we had this week, and especially because this is not a topic that we really talk about um, as we move forward. If you saw in chapter one, we know we have these different types of sampling techniques, and the kind of gold standard is random sampling. But in the real world, random sampling is really hard to do. You'll find that out when you start doing your sampling for your quantitative project. So, what I wanted to stress in this video, a lot of people say that the sample size is not big enough, and that's a common thought process, right? Like you need to go out and get more pieces of data. But keep in mind, and I've said this in the discussion, more data costs time, and it usually costs money. For your quantitative project, it won't cost you money necessarily. It's just going to cost you more time and more work. And so the sampling technique is more important than the sample size. Now, I'm not saying, if you have a good sampling technique and you only get two things, then you're okay. No, that's not what I mean. I mean, in general, you want to make sure that you have a representative sample at the end of the day. And the sample size, as long as you have some data, is not as important as the way that you got the data. So, what I wanted to illustrate here is that I have two different populations, and the sample size really comes down, like how big of a sample size you need really comes down to how spread out the data is. In chapter 3, we'll refer to that as standard deviation when we're working with quantitative data. We don't really talk about it in chapter 3 with qualitative data, which is what I have up here. So with quantitative data, we have a numerical measure. It's called standard deviation. There's other ones, but standard deviation is the one that we're going to work with. With qualitative data, the higher standard deviation is the one where you have the most disagreement. And that sort of makes sense. If you think about how spread out data is with quantitative data, you can think about the heights of people or something. You're looking at how different, really, basically, all of the heights are, how much disparity there is in the heights. With quantitative data, you don't really have that because you only have two options. It's either this or that. And so, for the purposes of talking about standard deviation, or it's not standard deviation here, but for the purposes of talking about deviation, you're looking for the most disagreement. And the one on the left is the one where the population is the most in disagreement. It's the most disagreement you can have in a population where the population is split down the middle, 50-50. Over here on the right, we have 90% of the population feeling one way and only 10% of the population feeling another. That means this population is in way more agreement than this one is. So 50-50 is the most disagreement you can have. And what I want to show you here is, let me say this again, you're not really going to get to know what's going on in the population when you get your sample. Right now we kind of get to peek behind the curtain, but the point of this is that if you have good sampling techniques, and what is happening in these applets is random sampling, so these are, the gold standard, is that when I sample out of the one that has the most disparity, notice that my samples, I'm going to do several samples, and every time I click this button, right, it's grabbing a new sample of 30, and it's dropping a block down here where that sample was. These are still going to bounce around 0.5, right? Now, keep in mind, in general, you're only going to go out and grab one sample, right? But it's got to be one of these, essentially, because these are all the possible ones. So I'm just clicking the one time over and over and over again. And notice how spread out my samples are. Notice, I think some of you called it erratic when we were talking about sampling when I showed you the other video. So with this one, notice that the samples are still bouncing around 0.5, but you have a higher chance of kind of getting away from what's really going on in the population of 0.5. Whereas if you over here, and again, remember, we only have 30 things in our sample. We could be talking about populations of millions or even, billions if we're talking about the world population. If I sample out of this one, you're going to notice that the blocks stay really close to what's going on in the population. So notice here, now remember the 90% of the population feel one way, so we're going to stack up around 0.9 on the right graph. Over here, we're going to stack around 0.5. So notice how much tighter the blocks are around 0.9 than they are around 0.5 on the left-hand side, right? I'll get this up to 58, but it really won't matter. They're not going to deviate that far from 0.9. Get these to be the same. Because there's not as much disparity in the population of 0.9. So really, it's again, I know it's common to think this way, but it's not about the sample size necessarily. It's about how spread out the data is. Again, moving forward in your book, you're going to be assuming random samples. So, a sample size of 30 or 50 is actually pretty good no matter how big the population is. It's not about the population size. It's about how spread out, how much deviation there is in the population. So qualitatively, you're looking at disagreement. The more disagreed, the bigger the sample size you need to get a better estimate. Whereas if your population is in more agreement, then the sample size doesn't really have to be that big to get a sample that's really close to what's going on in the population. Again, here you're hoping to get something close to 0.9, even though you wouldn't know the 0.9 in the real world. Over here, you're hoping to get something close to what's going on in the population, aka 0.5. But notice there's a much higher chance that you grab one of the samples that's not close to 0.5 because the population is more spread out, aka more in disagreement. Again, this is really about the sampling technique, so I just want you to think about this. I was thinking about this as I was reading your posts again in a couple of the forums. So I hope this helps. You got any questions, by all means, reply to the discussion thread. Look forward to your thoughts and your questions.